Jupiter is just a brownish-brown gas blob, huge and nothing special. In fact, looking at its other siblings in the family, we see Jupiter ain't nothing special. Mercury is the planet closest to the Sun. Venus is the brightest planet. Earth is the only planet with life. Mars is Earth's twin. Saturn has beautiful rings. Uranus has a bizarre axial tilt. And Neptune is the farthest planet. So what does Jupiter have surprisingly? Jupiter has more stories to tell than we think. Hello to all no one and welcome back to the channel with no viewers. Today we will go to the largest planet in the solar system, Jupiter. Though named after the king of Roman gods, this huge gas planet does not stand out in the night sky like other planets. More precisely, though visible to the naked eye, Jupiter does not leave much thought. Almost all ancient astronomers only considered it a star in the sky rather than the great celestial body it is today, because it can be detected by the naked eye. Jupiter does not have a specific discovery day. However, most astronomers agree that the first research on this planet belongs to Galileo Galilei. After having the first telescope in 1610, Galileo recorded a lot about the celestial bodies near Earth. Of course, the first celestial body Galileo studied was the moon, the largest thing in the night sky. And surprisingly, the next celestial body was Jupiter. After observing this distant planet, he recorded objects like small stars flying around the planet. These were Jupiter's moons. In addition, with the development of telescopes, more and more records and measurements of Jupiter were revealed. Contemporary astronomers understood that Jupiter is a huge gaseous planet with the main material making up the planet being gas, hydrogen, specifically accounting for up to 99% of the planet's mass. In addition, things changed Jupiter's mass and position. Astronomers hypothesized that it was the first planet formed in the solar system, not surprisingly being right outside the asteroid belt, and also the largest planet. It naturally had the most time accumulating materite of all. But exactly how big is Jupiter? Jupiter, like Saturn, is a huge gaseous planet. Through the solar system formation process, gases were pushed out from the center and gradually accumulated into huge gas blobs. In addition, thanks to the great distance from the Sun, these planets are also less affected by the radiation from the central star. As a result, they have properties that no terrestrial planet has. For Jupiter, it is the fifth planet from the Sun, the first place to enjoy the gases pushed out by the star. It is possibly due to this perfect position that Jupiter received the most gas, becoming the largest planet in the system. The radius of the planet is 69,911 km, equivalent to being able to fit over 1,300 Earths inside Jupiter. Let that number sink in. We are just specks of dust compared to the blue planet, and the blue planet is not even 1,000th of this gas giant. In addition, Jupiter is also so gigantic that it is 0.1 of the Sun's mass. This number may not sound big, but when we add the information that the Sun contains up to 99.86 of the total mass of this entire planetary system, Jupiter is truly enormous. Jupiter is so massive that its gravity affects even the Sun, while all other planets have to succumb to the tremendous gravity of the star. Jupiter says it does not care. Due to its weight, Jupiter not only orbits around the Sun, it also pulls the Sun with it, causing the two celestial bodies to orbit around an invisible point between them. This invisible point is called the barometer, roughly translated as the center of mass, the balance point between celestial bodies or the center of their orbits. In short, while all other planets have a one-way relationship with the Sun, Jupiter is so heavy that it gives and takes. It's not all. If we take the mass of the remaining planets in the solar system, add them up and double it, it still cannot equal Jupiter's mass. It is clear that to talk about the enormity of this planet, we could spend a whole day making comparisons. Anyway, this is still the big sister, the largest planet in the solar system. Its enormity is a given. But is this blob only about its gigantic property? Jupiter looks chubby, but in fact it is one of the nimblest planets in the solar system. Of course, with its position as the fifth planet, its orbit cannot be shorter than Mercury, the messenger god's planet. Instead, the king of gods has a dizzyingly fast rotation speed. One year on Jupiter is 4,333 Earth days. However, 1 day on Jupiter is only 9 hours 55 minutes on the blue planet. Standing on Earth and gazing at Jupiter, we will see it stationary in the sky. However, looking more closely, we will see a spinning top spinning wildly in the sky. The equatorial rotation speed of Jupiter is 45,583, 9 times faster than Earth. Standing on this planet, we will only see streaks of light in the sky and as the surrounding planets and stars all drift by at breakneck speed. However, actually standing on this planet is purely a hypothesis. As a huge gaseous planet, Jupiter's surface is nothing to stand on. It is mainly composed of huge ammonia clouds and contains terraforming storms occurring across centuries. One of the most recognizable features of this giant planet is the red spot on its surface. This is not a mountain nor a meteor crater. This is a storm. No one knows exactly when this storm was born. We only know that since Robert had discovered it in 1664, it had been there. Over time, astronomers gradually paid more attention to this red vortex. However, observing from Earth would hardly produce more results about it. Hence, space telescopes were put into operation. Surprising results came to humankind. First, the actual size of this storm is terrifying. The radii of Jupiter's storm has a diameter equal to 3 Earths. However, this number is changing. Through detailed observation from the Hubble telescope, this storm has shrunk over time, from the size of 3 Earths. Now it is just slightly larger than Earth. Though shrinking, that does not mean it is weakening. The storm's average wind speed has increased by 8 in recent decades, and the storm is also gradually changing shape, from an ellipse to a circle. Why is this happening? To answer that question, we need to send probes to this giant planet for further study. This is what we have done many times with other planets. We just need to launch rockets into orbit. But with the monster named Jupiter, everything is not as simple as that. With its massive mass, Jupiter's gravity is a major challenge for any voyage to this planet. The pressure generated from Jupiter can tear apart any object daring to come near it. Therefore, to be able to approach this planet, we need to calculate the flight path very carefully. That is the first challenge. So what is the second challenge? Jupiter's core is a solid hydrogen mass. The comet's tremendous pressure compresses hydrogen into solid chunks with metallic properties. This means that this planet also has a magnetic field like Earth, all much stronger than our planets. Specifically, Jupiter has the strongest magnetic field in the entire solar system. This magnetic field not only protects the planet from solar storms and creates huge vertigo-lines, but the power of this magnetic field is strong enough to harm spacecraft, and especially astronauts. Discoveries about Jupiter's environment came to humankind very early. Therefore, the process of coming to this planet was very thoroughly prepared, avoiding unnecessary losses. In 1973, the first voyage to this giant planet departed. That was the Pioneer 10 satellite, launched in December 1973. However, this was just a flyby to collect as much information as possible before moving on. 6 years later, the Voyager 1 and 2 missions departed, and these trips brought back to humankind the first information about Jupiter's moons, volcanoes on those moons, and especially its asteroid belts. Yes, this planet has asteroid belts like Saturn and Uranus. It is much thinner and more blurred than the above 2 planets, which is why it could not be easily detected as we thought. Over time, gradually understood more about Jupiter's environment and began sending more satellites. The most special voyage to this planet departed in 2011 of the Juno satellite. Juno is a flying tank, fully equipped with the most advanced tools to both detect everything on the gas planet and withstand the challenges this planet poses. And indeed, Juno accomplished much more than humankind expected of it. In 2016, Juno reached its destination and began the process of exploring, researching, and transmitting data back to Earth. Initially, Juno only had the 53-day mission of hovering above Jupiter's clouds to take pictures, scan atmosphere's properties and parameters. However, the favorable situation after the trip allowed Juno to extend its mission duration. And from that we had greater discoveries of this giant planet. Jupiter's atmosphere is the first thing we can study. Its shape consists of many cloud bands with winds blowing in opposite directions. This is a phenomenon that also occurs on Earth, but on a much more terrifying scale due to the planet's thick and deep atmosphere. However, the color of each cloud band is different. Some are really brown, some are white. The color of each band shows the interaction of ultraviolet rays with this planet. Different interactions create different colors. In addition, storms also occur frequently on the planet. Many vortexes intertwine with each other and swirl together on the edges of the planet's huge cloud bands. Meanwhile, the planet's famous red vortex has two sisters next to it. In addition, the red vortex is also very deep, with the vortex base possibly as deep as 350 km. According to the information gathered about the storm, though we cannot be certain, this red storm may be a permanent feature of the planet, meaning it has existed since the planet's birth, and exists forever. Though we cannot conclude whether the red storm is eternal or not, we can be certain the storms at the planet's poles are eternal, unlike Saturn's mysterious hexagonal shape. Jupiter contains a new kind of hell. At the planet's south pole are 5 huge, swirling into each other, radiating mystical blue light. Meanwhile, at the north pole of the planet are 8 swirling vortexes. These storms are kept steady thanks to the planet's rotation. In addition, with the break speed of the equatorial winds, the planet can continuously supply the necessary convection to keep strengthening the stirrings. With Juno's scanning ability, we also discovered more about the lowly layers of the dense clouds. Jupiter's atmospheric layer has temperatures up to 700. Going deeper into the planet's liquid hydrogen layer, the temperature doubles, possibly up to 3,500 X2. After that, in the solid hydrogen layer, the temperature can reach from 4,700 to 5,000. Finally, at the planet's core, where matter can only be hypothesized, the temperature will exceed 19,000. Jupiter radiates out more heat than the solar energy it receives from the Sun. But this is just a glimpse of the planet. Juno's journey also takes us past the moons of this giant monster. Ganymede, the largest moon in the solar system, and Europa, the planet's gorgeous moon, were both objects studied by Juno. But that will be content for a reunion. Jupiter is still a mysterious planet with many unanswered questions. And that is the promise that when we have the opportunity to return to this planet, we will continue to explore more. And that was the story of the largest planet in the solar system, Jupiter. Though not as perfect as its many near neighbors, Jupiter still carries its own mystical, alluring aura of mystery. When Sophia, we still do not know too much about Jupiter,